Hello everyone. The next program we have in our data structure application laboratory series is program 8, that is implementation of doubly linked list. That is number of operations we are going to implement on doubly linked list similar to singly linked list. So here this picture represents the doubly linked list. So here we can see that unlike singly linked list, in doubly linked list the node will have three parts. So one is the left link, that is one is the left link, the other one is the information part, then one more part is the right link. So that means each node is going to have three partitions. One is pointing to the left link, that means this link will be holding the previous node's address, and the R link will be holding the address of the next node. So, and the student record information will be as usual, that is student name, USN, branch, SEM and phone number. So here either we can implement the doubly linked list by using a single pointer, or we can make use of two pointers, one pointing at the start node of the list and the other pointing at the end node of the list. So before we exactly move into the implementation of doubly linked list and know the theory of doubly linked list, so myself Shanti DL, Assistant Professor, Department of ISC and BMSIT and M. Our question on doubly linked list is like this: design, develop and implement a menu-driven program in C. The following operations are on doubly linked list of employee data with fields SSN, name, department, designation, salary and phone number. So instead of student record, we are going to maintain an employee record here with these many fields, that is SSN, name, department, designation, salary and phone number. So the first operation here is to create the doubly linked list for n employees data by using end insertion. So here each new record for the employee is going to be inserted at the end of the list. And second option we have is a display the status of DLL and count the number of nodes in the list. Perform insert and delete at end of DLL. Perform insert and delete at front of DLL. And also demonstrate how this DLL can be used to simulate the working of double-ended queue. The last option is exit. So before we move exactly into the implementation, first we should know the theory of the doubly linked list. The doubly linked list is similar to the singly linked list. The only difference is that in doubly linked list, each node contains two links. The first link points to the previous node, or the L link points to the previous node, and the next link points to the next node in the sequence. So this is a picture which is similar to. So here for simplicity we have taken an integer data here. This can be any multiple data record itself, like employee details or student details or records can be inserted here. So here we are maintaining two pointers. One is start pointer and end pointer to indicate the start of the list and the end of the list. So here we have a little more formal representation of doubly linked list in computer science. Is a linked data structure that consists of a set of sequentially linked records called nodes. Each node contains two fields called the link that are references to the previous and to the next node in the sequence of nodes. The beginning and ending nodes, previous and next links, respectively, point to some kind of terminator. Typically, a sentinel node or a null node to facilitate the traversal of the list is given. So the L link of the first node will be null and the R link of the last node will be null to indicate the end of the list we have here. So if there are only one sentinel node, then the list is circularly linked via the sentinel node. So it can be conceptualized as two singly linked lists formed from the same data items but in opposite sequential order. So here it is possible to traverse in both the forward direction as well as in the reverse direction also, because each node contains the address of the next node as well as the previous node. So a doubly linked list whose nodes contains three fields: an integer value, the link to the next node, and the link to the previous node. The two links allow traversal of the list in either direction. While adding or removing a node in a doubly linked list requires changing more links than the same operations on a singly linked list. That means the amount of operations required or the pointer exchange requires is more compared to the singly linked list. The operations are simpler and potentially more efficient for nodes other than the first nodes, because there is no need to keep track of the previous node during the traversal or no need to traverse the list in to find the previous node, so that its link can be modified. So the single linked list contains only one pointer and the double linked list contains two pointers to be modified. So to implement the double linked list operations, first we need to declare the structure. So this structure contains the employee details like SSN, character, name, character array, and department, a character array, designation, a character array, and phone number, salary of the employee, a float, int and float respectively. Because as we saw, the node contains two links. One is L link, the other one is R link. So similar to our single linked list creation, even we have the node as taken as a typed as struct node. So this is going to indicate the entire structure here. And here, as I said, as we discussed in the first diagram, that is, it is going to maintain two pointers. One is the first pointer and the second and the end pointer. So to point to the first and last locations of the list. So initially we create a temporary node called temp, and here we are using one more function called getNode function, so which is generalized function. Whenever we want to create a node for each time, instead of going for the malloc function multiple times, we can call this function to get the memory allocation by using this getNode function. So in this getNode function we are declaring a temporary node. So for this node we are allocating the memory size in the same way by using the malloc. And the next function we have is the read function. So this read function is to read the details of the employee record. So here first we declare, because in the initial itself we have taken a temp node, and here we are allocating the memory by using the getNode function here to temp, and we are making temp r link and l link is equal to null. So initially we are creating a node which is having three fields like this. So in this we are going to have a node. So in this node we have the first part pointing to the L link. This is we have L link, and here three parts are there in the node. So this is our L link, and this is R link, and this is the EMP record. EMP record we have. So this each node is going to be of this sort. So we have a link made null and R link made null. This is our temp node. So we can call this as a temp node. So this temp node is now it's not contain it is not containing any data. Only we have created a node and we have allocated the memory and made L link R link is equal to null. These two we have made it as a null. And here after that we are going to read the SSN number of the employee, and then name, department, designation, and then phone number, and the remaining details also we are reading it here. So we are reading the details of the employee record. So all these details will be read, and temp salary will be assigned with salary. So this is just a creation of a node and allocating the data to the employee data to this particular node temp. The very first option in the menu we have is a create doubly linked list. So here we're going to read how many employees data we need to put it in the list. So we're reading the n value, and accordingly we're going to call the read operation. So many number of times we're going to call the read operation. So after each return from the read, one node will be created and the data will be inserted into the particular node. If the first node is null, that means I don't have any nodes in the list. So then we have made in the beginning itself the first and end is equal to null. If first is equal to null, it indicates that we don't have any nodes in the list. So make the temp itself as the first and the last node. That is, the both first and last will be end will be pointing to the temp node itself. If not, so if this is not, so as we can see in this particular list, so if front is equal to null in this, first is equal to null in the sense we don't have any nodes in the list. So first and end will be the temp node itself. If not, if this condition is wrong in the sense there are set of nodes in the list, so it has been given that while creating we need to insert the new node at the end of the list. So this node will go and will be attached at this location. So that means this will be the end node. So how are we doing this one is, because end of r-link is null previously. So what do? We are going to place the address of this temp in this particular locations. That means we are going to create a link here by placing the address of the temp node in this particular location. That means if I consider the address of this temp node is 400, so this 400 will be placed in this location. So that means end r-link will contain the address of the end r-link will contain the address of the temp node, that is 400, and temp l-link is equal to end. So what is the address of the last node is 300, so that will be placed in this location. That means to say we have established a link from the end of the list to the temp node, and now by placing the address of temp l-link, so this is our l-link for temp, so this will be placed with the address of the previous node, that is 300 will be placed here, and a link will be established, that is to point to the previous node, a link will be established here. So like this we have added the new node temp at the end. So that means end r-link is equal to temp and temp l-link is equal to end, and end is temp. That means we are replacing this temp with the end. So this is my new end pointer for this new list created after adding a temp node or a new node. The next operation we have in the list is display and count the number of elements and also the data of the records in the list. So here node temp1 is equal to first. That means I am making this node as the temp1 node, and int count is equal to 1. So we should initialize this with 1. So it should be 0 actually. And then if the employee details are like this, if temp1 is equal to null, the employee details and the count will be displayed. That means if I have the first node in the list, and if not, it is going to display if there are more number of nodes in the list. So here it is going to display that in the loop. That means if until temp1 reaches to the end, until temp1, this was my temp1 first, so until I'll reach the last node, so I should that the details like SSN, name, department, designation, salary and phone number will be displayed. So count will be incremented parallelly, so as the temp moves on to the next location by using temp1 is equal to temp1 R link. So by using this R link, the next node information we are going to get. So this is to move from one link to the other link. It is one node to the other node it is given. So this display function will display all the elements of all the nodes of the W linked list. One more function we have here in the W linked list is insertion at the front. So this is my insert at the front operation. Basically we are going to read the details of the employee to what particular record I'm going to enter, so that will be read through the read function. If first is equal to null, that means no nodes are in the list, then I'll make that temporary node, the newly created node itself as the first node. If not, what we are going to do here is, this is what the list we have now, that is insert front. So if first is equal to null, so the temp itself will become the first node. Temp itself will become the first node. If not, if I have the list like this, then temp of R link. So this link should be placed with the first. What is that first is holding is the first node's address, that is 100. So 100 will be placed here. So in this particular location, 100 will be placed after this particular statement. So that means, so temp R link will be holding the address of the first node. So that means here we are going to have the value as 100. So first L link. So this L link should hold the address of this particular node. So how we are doing this is, first of L link, this is my first of L link is equal to temp. So that means I'm going to replace this null value of the first node with the address of the temp node. So that means what is the address of temp node? So that address will be placed in this particular first node, that is 400 will be placed. That means I have established a link, forward link from temp to first, and from backward link from first to temp we have done the link. So my now first is temp itself. That means whatever the previous first node, the first pointer was pointing, now it will be pointing the first is equal to temp will make, that means 400 will be placed at this location. That means this will be placing with the address 400. So this 400 will be placed in the first node. So this is my first node now, so that address will be returned, or this is the first node now. So insertion of the new node is done at the beginning. So in the previous function we saw that how to insert the temp node at the beginning. Now we are going to look into the other function called inserting a node at the end. So similar to the previous one, we have to get a node temp, then make temp R link and L link is equal to null, and then read the data of the employee for this temp node. And if null is first is equal to null, that means if no nodes are existing in the list, first and end will be null. So in that case, this node itself will become the temp node itself will become the first and end node. That means only one node I have in the list. If not, if this is not the condition, if first is not equal to null, then we are supposed to add this new node to the end of the list. So how do we do that? Because we have an end pointer which is pointing the last node and the first which is pointing to the first node of the list. So by using this end pointer, we can easily add the node to the end. So that can be done by replacing the end node r link is equal to temp, end node r link is equal to temp, and temp l link is equal to end, which we have done while doing the creation itself. We have done the same way. So this is going to be like this. So here we are going to place the value 400, that is end r link is equal to temp, and temp l link is equal to end, temp l link is equal to end, that is 300 will be placed. So the link from end node to temp is done, and the link, the previous link of the temp should point to the end. So this is how the new node will be added to the list, and this will become the end node. Similar to our insert front, insert end operations, we have delete front and delete end operations. So delete front means the node which is at the beginning of the list will be deleted. So the function goes like this. We are going to create a temp variable. So this is required to track the node for the next node. So if first is equal to null, we are having no list. That means list is empty. If it is not so, if first is equal to end, if first is equal to end, that means we have only one node available. So that node will be taken as the first temp node. First node will be assigned to temp 2, and record with the data will be SSN will be displayed, and make both first and end is equal to null. That means there are three conditions which can appear here. One is either the list is empty. In that case, we cannot delete any node. The second case, the list is having only one node. So in that particular case, we are going to delete that node and make this first and null is equal to first and end is equal to null. So if this is not the condition, means there can be more than one node in the list. So this is when the first node, the list is empty. This is when only one node is existing. If this is not also true, then we are going to have more number of nodes. So we need to track the remaining nodes. We should not lose the starting address of the list. So we'll store that address, first node's address in the temp2, and display the first node's details here with SSN. So here temp2 is pointing this location. So that means we have made temp2 to point to this particular location, that is, this is my temp2 where I stored the address of the first node. So we should not lose the address. So I made temp is equal to temp2 is equal to first, and then first is equal to first R link. So what I am doing, my first will be assigned with first of R link. What is there in the R link? R link is having the address of the next node. So I'll be taking out the address of the first here, taking out the address from the first node. So I'm assigning here the address as 200. So this will be assigned with the value 200. That means first will be now pointing to this particular node. That means first R link will be pointing to this particular node, and make temp L link is equal to temp2 L link is equal to null, and free the temp L link temp2 L link. So that means this L link what we have will be made is equal to null. So here this has to be made equal to null so that I can disconnect this particular node from the list. So make this as null. This will become null here. This will be null, and the link between previous first node and the new first node is been broken. So now this node is been pointed by temp2. So this should be first L link is equal to null. So here we have seen that first is equal temp2 is equal to first, and first is equal to first R link we have made, and first L link should be made null. That means this is first L link. So there is a mistake here. So first L link is equal to null, and now this has been disconnected here, and free this temp to now, and this is the function to delete the first node in the list. The next function we have in the delete operations on doubly linked list is delete at end. So just now we saw how to delete a first node in the doubly linked list. Now we should demonstrate how the last node can be deleted from the doubly linked list. So here we have temp2 as end. So we know we have two pointers, so that the end will be made to point to the temp2. So here this temp2 will now point to this particular node. So in this particular case, the temp2 will have the address of the end node, that is 300. It will be holding the address of the last node, that is 300, will be in this location. And if temp2 is equal to null, temp2 is equal to null, that means if it is equal to null, then this should be end is equal to null. So if end is equal to null, in the sense list is empty. Else if the similar way what we have followed, delete an element from front, here also we have three cases. One is when list is empty, the second one is when only one node is there, when there are multiple number of nodes are there. As we know that doubly linked list can be traversed in both the directions, forward and backward. So here the first conditions test that whether the link is whether the list is having any nodes. As here we can see that first temp2 is made point to the end. So this is point in the end node. If temp2 is equal to null, or we can make end is equal to null, then list is empty. If not, if first is equal to end, that means only one record is there in the list or one node is in the list, then print that is a number and make first and end is equal to null. Else, if there are more number of nodes like this in our example, so in that case what do we do is end link is equal to end is equal to end link. So we know that doubly linked list can traverse in the both forward and backward direction. We'll try to make it end as this node, that is end link is end is equal to end link. What is there in the link? That address of the previous node. That means to say I am going to create a link between end node and the previous node to the end, and now end R link. So this, now we have made this end is equal to end link. That means this becomes a end now for us. So there is no link between these two. Now what happens? So this end is pointing this node and end R link. What is end now? End is this node and R link of this node is this 300. That means there was a forward connection between this previous node and the last node. So that we are making it as null. So this value will be taken out, and here we are making end R link is equal to null. So that means the address which was there 300 of the last link, that will be made as null here. That means we have cut the relation between this node and the last node. So now this node is independent and this is being pointed by the temp2 node. So we can easily free this temp2 node, so that now my end is this and the first is this node, and this node can be deleted. So after temp free temp, so this node will be deleted completely, and this will become your last node or end node. So the next one we have is we need to demonstrate the DQ operations. DQ is nothing but double-ended queue. So double-ended queue means we can insert the element and delete the elements at the beginning, and similarly we can insert or delete the elements from the end also. So that is what this double-ended queue here is. So if you have understood how the insert front, delete front, insert end and delete end are working here, the doubly linked list previously, so doing this double-ended queue, demonstrating or simulating this will become very easy. So here what we are doing, the choices are like either you can insert at the front and insert at the last and delete at the first and delete at the end. So these are the four operations simultaneously we can call to demonstrate the double-ended queue operations. So that means double-ended queue means both the ends are open, so I can either insert or delete at both the ends is nothing but the double-ended queue. So that operations can be easily demonstrated by using the insert front or insert end, delete front or delete end, and display the count of nodes in the list. So this main function is nothing but just calling of all the different operations which is specified in the question. One is, first option is create a doubly linked list, display the doubly linked list. This should be a doubly linked list, and insert at the front, insert at the end, delete at front and delete at end, and also demonstrate the double-ended queue. So here we have going to put all these options in the continuous loop. So in the switch case, we have creating a DLL, displaying count number of nodes in the list, inserting at the front, deleting at the front, and inserting at the end and deleting at the end, and also demonstrating the double-ended queue. So based on this choice, we are going to enter into any one of this. So to do any of these operations, first we need to create the double-ended double linked list. So this is done by using the create operation, which we have called in the beginning itself. So this is all about the double-ended double linked list operations. So this, by using this set of operations, we can demonstrate the double-ended queue also. Thank you.